Okay, the next question is now what do we do? So we've run a study and we found a probability that's really small, which means the null hypothesis that we had made on the previous question was wrong. So now we ask the question, okay, where is the true population parameter going to fall? Because the null hypothesis was our only guess that we had for that before. Well, let's go take a look. The thing we're going to build is what's called a confidence interval. Okay, so the question is, what is the true proportion? So we've rejected the null hypothesis, but we want to know where the true proportion is. So a confidence interval is a range estimate for where we think the true statistic lies. And from our textbook, there's a great little phrase that I want to read here that I think encapsulates the entire idea. So a plausible range of values for the population parameter. In this case, the population parameter is the percent of people that we talk to who will choose this left-hand guy to be a Tim. All right, so that range is called a confidence interval. Using a point estimate, like our 78%, is like fishing in a murky lake with a spear. Using a confidence interval is like fishing with a net. We can throw the spear where we saw the fish, but we'll probably miss. The analogy being here that if we try and extend to a different group of people and ask them the same question and presume that exactly 78% of them will call this left guy Tim, we will be wrong. We will miss the fish. Whereas if we throw a net and say, well, it's between this high 60 something and maybe low 80 something, then we're way more likely to be correct. That's the idea of a confidence interval. You gather data. Your data tells you one point of information, but you have to fully admit that your data is not the only data that could exist. So you cast a wide net and say, if I were to gather this data again, here's where I think things are going to fall. Okay, so a little bit more of the details. If you've rejected your null hypothesis, you've admitted that your null hypothesis was not correct. So now I can use the data to cast this wide net. What we're going to do is we're going to take our data point as our center of our interval, or center of our net, for example, and then we're going to use the normal distribution and standard error to help us build the size of the net. So some terms that we need, and the math gets a little complicated here, but I'll walk you through one. A point estimate is what you get from your data. The standard error is the spread of a sampling distribution centered now at your point estimate. And then the margin of error is how far you're willing to reach out left and right in order to say, hey, here's the range I want to give you for where the true population of people that would say the left-hand picture is Tim is going to be. Now, let's go through an example. It's going to be way easier if I just have an example in front of us. Okay, so here's our data again, or here's our data and our hypothesis test that we had before. So in our sample, the number of Tims on the left was 36. The sample size was 46, right? Remembering that from the previous video. So the proportion that we have is our 36 out of our 46, right? This is our p hat, right? Our sample proportion. Let me rename that sample proportion. So we saw 78% of the people in our sample say, oh, Tim is the guy on the left. Whereas we know that's not going to be the case if we took the sample again, even from a slightly different population. Okay. Let's be 95% confident when we report our answer here. And if I was to report exactly 78% of all people would choose Tim to be the left-hand picture, I know I'd be wrong. But I want to be really sure if I'm going to report this result. So I'm going to say it's between something and something. And I'm going to quantify how sure I am by saying I'm 95% sure. Okay, now what that gives me is a normal distribution. Or I'm sorry, it gives me information about a normal distribution. The center 95% of a normal distribution is plus and minus 2 standard deviations, just about. Now that we have some better tools, I'm going to get something slightly more precise than my 2 standard deviations. Right? I'm going to do norm dot S dot inverse. Now the S here stands for standard, because I'm going to pick up a z-score. And I want the z-score that captures the upper cutoff for 95%. Well, that is my 95% plus the tail that's underneath that. That's 0.025. Okay, notice that that's about 2. So there's 97.5% of a normal distribution below the cutoff. That gives 95% in the middle. Okay, now it might be helpful to have a picture. Let's see if I can annotate on top of this. Okay, so if I come down here, I've got a nice clean spot. All right, so I've got a normal distribution here. I want an interval that gives me 95%. Well, that means I have 2.5% sitting over in each tail, right? Because 2.5 plus 2.5 is 5%. So I've got 2.5 in the left-hand tail and 2.5 in the right-hand tail. And I wanted this z-score right here, and that captures 95 plus 2.5. There's where my 97.5 came from. So notice I had 95 for the middle that I wanted, and 2.5 for the left-hand tail. That's now the z-score that gives me 2.5%. So what I'm going to do is I'm going to reach now from my point estimate, which is right here in the middle, this many times the standard error out, and I'm going to find my margin of error. So let's get my standard error. Right, that is the square root of my proportion times, I'm just following this formula, 1 minus my proportion divided by my sample size. And notice again, I don't have too many parentheses. I start 1 for the square root and 1 for the square root. Start 1 for this parenthesis and 1 for that parenthesis, and that's all you need. So this is the spread of the sampling distribution centered at our point estimate. Okay, now following a little bit further, my margin of error is my critical z-score times my standard error. So my margin of error is literally just this thing. That's it right there. That is my margin of error, right? Abbreviated MOE, margin of error. Okay, so now if I'm going to report out how big the interval is, or I'm sorry, if I'm going to report out what percent of people I think are going to pick Tim to be on the left-hand side, I'm going to report out a lower estimate, and I'm going to report out an upper estimate. And my lower estimate is going to be my point estimate minus my margin of error. So that is my 78% minus my margin of error. And my upper estimate is going to be my point estimate plus my margin of error. So now I have a statement that I can say. We think that between 66% and 90%, rounding a little bit here, of people will choose Tim to be the name of the person on the left-hand picture. Okay, now what I just did was a little bit complicated, admittedly. So I need you to actually just go back and watch this video again now that you have kind of the whole picture, And then I'm going to ask you for a slightly different confidence interval, right? I'm actually going to change the situation just a little bit.